So about the best fit line, we had seen the points through it, and we have a line best fitting those group of the points with the equation y hat equal b0 plus b1x, where x is the independent variable. Y is the dependent variable, and inside b0 is the y-intercept, b1 is the slope. What we have is, well, the point in the arbitrary have the y value, but for the line here we have the point of x, y hat, right? The distance between the point points of y value data and the predicted y hat. For any line that will be 0 no matter what we do, if that's best fit enough, and if it's a good line, right, we need to make sure that y minus y hat equals 0. Not only that, right, but also the square of it needs to be the smallest value. Right, so what we need to do is to minimize this sum of the square of the residual. Right, the residual is the data value and the predicted value, their difference, right, between the data and the predicted value. Where our hat is b0 plus b1x, and variables are b0 and b1. Right, there in calculus we will have the way to minimize the function. Right, here is the summation of functions with b0 and the b1 are our actual variables. Right, the y, the x, they are given data in our case here. Right, so that's what we are doing. Then, in conclusion, right, if AR is big enough, the line exists, then our B1 is SSXY over SSX, and the B0 is Y bar minus B1 XY. Right, so that is the thing that, well, R is large enough that we're able to find B1 and B0 similar way as we find the RS already. We find those sum square of errors of x, y, and the interacting xy, that we use them, two of them, right, to find our B1, and then use the mean of x and y and B1 to find our y-intercept. The line pass through the points. First of all, it has to pass the y-intercept and also has to pass the average. Right, two special point they're passing, so when we draw the curve, or not curve, when we draw the line, or we could use just b0 and x bar y bar to find them, right, as the end. Right, so let's see an example how to find those. We'll leave some space since we do not have enough space over here, so maybe the result we need, we'll put it on the left side. Right? So given the table, one 7, 2 9, 2 11. 314, 450. Right. That's all we need for the table, right? That table is part of the question will give us also. Right, so from that, we can find the product. 7, 18, 22, 42, and 60. X squared, that's square of x. 1, 4, 4, 9, 16. And the y square will be square of y. 49, 81, 121, 196, 225. Right, therefore, we will find our sum of x, that is the sum of this column, 12. Sum of y, that is the sum of the second column of y, that is 56. Sum of xy, that is 149. And so on. We'll get 34 for the sum of x squared and sum of y squared in the last column, that's 672. Right, so those 5 values are what we need. Right. From them, we're able to calculate out our SSX, SSY, SSXY, and the other values, like the x bar and y bar. So SSX, if you still have the formula, right, that sum of x squared minus the square of sum of x over n, that sum of x squared is 34 minus 12 squared which is 5.2. SSY, the same way that sum of y squared minus sum of y squared over n. Sum of y squared 672 we found. Sum of y that's 56 divided by 5. 672 minus square root of 56 squared. Square root of 56 over 5, that is 44.8. Right, so those values are what we need. 5.2, 44.8. Right, and SSXY, that is the sum of XY minus x y over n, which we found sum of xy is 149 minus sum of x is 12, sum of y is 56 over 5. That will give the value of 14.6. Right, and then the x bar, y bar, maybe also we could put it over here, right, before we move on. That's sum of x over n, 2.4. Y bar is sum of y over n, 11.2. Those are the values we need and the calculation on the right side. So we kind of do not need that table until we draw the scatter plot at the end. Right? So you could write the table of x, y values down. Right, then what else is we find out the R, right? To check to see if the correlation exists. R is sum square of xy over radical x y. That is, well, SSXY, that's 14.6. Square root of 5.2 times 44.8. So that will be 0.957. We had 5 points. So when we use the table A5 for critical R value, alpha is 5%, n is 5 in our case. Therefore, the critical R value is, we use the row and the column, that's 0.878. So what we compare is the absolute value of R, that is 958, and the absolute value of R is larger than the critical R value. Right, later on, we use the critical number to compare. We will have some other ways to do, but for now, that is what we have, right, for the critical value. Just find out the absolute value of R and see what we will have. Right, so once the critical is bigger than, once the computed correlation coefficient has absolute value bigger than the critical value, we can say that, well, we have enough evidence or sufficient evidence that xy are linearly correlated. Right, the evidence is from that the computed R is greater than the minimal requirement of the critical one. Right, from that, we're able to compute move on. Right? Move on to compute. Y hat will be B0 plus B1x. Right, from that, we're able to compute the line. Right? If it's not sufficiently large enough, then we are not able to compute the line. Right, the B1 is SSXY over SSX. That's 14.6 divided by 5.2. That's about 2.8076, and so on. 77. Maybe you can round it to 2.8 for the final value. And since we need to use that inside our calculation to find out B0, then maybe we keep more digits will be good, will be also better, right? That's 11.2, 2.8077 times 2.4. Or if this number is negative, then the entire calculation will become positive and will become larger. Just to be careful. 11.2 minus 2.8077 times 2.4. That is 4.462. We could round it about 4.5, right? 4.46, a little less than 4.5, but still appropriate. Right, so that's our calculation. Therefore, our line y hat equals B0 plus B1 x. Right, 4.5 plus 2.8 x. And the point we have is 0, 4.5, and also 2.4, 11.2. Right, that's 2 points we have. So finally, to draw the scatter plot. we'll get the values 5, 10, 15, and each one to be this down. Well, if you have the point recorded, we get 1, 7, right, the first point. 1, 7, 2, 9, 2, 9, 2, 9 is a little bit down, but anyhow, right, that's here. And 2, 11, 3, 14, and 4, 15. Right, that's our points. That's the scatter plot. And then what we have is the remaining. Right, there are the 2 points that the 0, 4.5 is here, the y intercept, and also 2.4, 11.2. Maybe somewhere. Let's a little down. Here. 2.4, 11.2, which is the x bar, y bar, right? That's a little, maybe somewhere here. Right, that is the x bar, y bar. This point is 0, b0, and connect them together. We get the best fit line. Right, and if you want to, you could make the dash line before the 1, since the first starting point is at 1 here, right? So we going through that, just use dash line to going through, but it's not that strict in our course here, right? Just use the line and go from the beginning to the end of the x value that we are able to process the line going through those points. So that is our best fit line. And well, next time we'll see about the probabilities. So thanks for watching. I'll see you next time.